Hi students, you are welcome back to another interesting aspect in physics. Although to students it's very difficult, but today I want to provide a lasting solution to it. Now, what are we talking about? That is the ray diagrams and their application. I want to assure you, if you pay active attention and you understand the concept, this will not only help you in understanding how to make the sketch, it will also aid your calculation, because by the time you understand various positions by which object could be placed, as well as different images that can be produced. Now, the moment you do that, you'll be able to what? To be able to pick correct option in your calculation. So what are we now saying? Now, in your previous class or at your lower level, you were taught different types of mirror. We have the plane mirror. It has its own characteristics, ranging from producing the same size as the object. We have the same distance as the object placed in front of it, and so many more. Today, we want to talk about the concave as well as the convex mirror. Now, let's see if I draw something like this. Of course, you cannot say whether this is a concave or it is a convex, because characteristic of a mirror is that it has one of its sides painted and the other side is left for reflection. Now, if I paint the outward, I paint it this way. Of course, this is a concave. This is a concave mirror. And this concave mirror has an imaginary line. Imaginary line that is invisible. You cannot see it, but it is there. Now, this point is labeled pole. This is called the principal focus, while here is called the center of curvature. The relationship between this and this is that half radius of curvature is what? Is the principal focus. That is, if I divide the radius of curvature by 2, I will have my principal focus. If you are given the principal focus, you should know that your radius of curvature is going to be twice the size of the principal focus. If that is understood, then you are in a way to getting the correct answer. Now, I have another thing like this. If I now paint the inward, if I paint the inward, that is, you have it protruding outside like this. This is convex. This is concave. This is concave. This is convex. Just as we can see in our spoon. This is what? This is concave, while the outside here is convex. Now, part of the characteristic of images formed by the concave is the convex. Is that understood? Now, as we progress, you can now see this one, it produces an inverted. Inverted means upside down. While this one always produces an upright image, irrespective of where the object is placed. But this one, it can produce inverted as well as upright, depending on the position where the object is placed. Now, as I said, just as this one has the pole, the principal focus, and the radius of curvature, so also this one too has the pole. Remember, I do not have anything here. This is the painted. Now, our concave, our convex. So we have our P, we have our F, and we have this. this is the reflecting surface for a convex, while this is the reflecting surface for concave. Now, I usually tell the students to get this concept into their score. Now, we have this. As I said the other time, we are dealing with concave first. Now, we have F and we have C. Again, I have another one. P, F, and C. And the last one, we have P, we have F, and of course we have C. Class, if you understand this principle, the concept, there is no any ray diagram that you cannot draw. Now, what are the principles? The first one says that any ray that is close and parallel to the principal axis. Where is our principal axis? This is, of course, this is our principal. This is our principal axis. This is our principal axis. Any ray that is parallel to the principal axis, after striking the mirror, is going to reflect through the principal focus. You must show the arrow because you have to show the path in which the light ray is taken. Now, that is number one. Let's go to number two. Any ray that passes through C after reflection, or any ray that passes through C after reflection, it will maintain the same path. This goes, this comes. And this one leads us to law of reversibility of light. If they ask you to state the law of reversibility of light, it simply means light that passes through the center of curvature after reflection is going to pass through the same path. That is number two. And the last one, any ray that passes through F. Here we have this. We have any ray that passes through F after striking the mirror is going to be parallel. This one strikes, this one is parallel. Is that understood? In concave mirror, the nature of image produced depends on the position of the object. Depend on the position of. Now, let us now see various positions by which an object could be placed. Various positions by which an object could be placed. Now, for easy understanding, let me just sketch. You now see, because I said I don't want students cramming. I have this, we have P, we have F, we have C. I can place one here, look at it. I can place one here. This is one. I can place one here. This is two. I can place one here. This is three. I can place one here. This is four. And of course, I can place one here, which is 5. So you can now see I have 5 different positions by which an object could be placed. If I place it 1, 2, 3, you see, it's just that I'm moving very close to the lens or to the mirror. I'm moving very close to the mirror. Now, let us now see. What if they ask me to describe this? It means the object is placed beyond C. That is number 1. The object is placed beyond C. 2, if I want to describe, the object is placed at C. 3, the object is placed between F and C. The 4th, the object is placed at principal focus, F. The 5th one, the object is placed between the pole and the principal focus. I believe it's understood. Beyond C, at C, between F and C, at F, between P and F. Those are the positions. Now, let me now see the nature of images that will be produced. Let me see the nature of images that will be produced. You now see that it is very, very important. If you use those 3 ray diagrams that I initially drew for you, you will not have any problem. Let's do the first one. The first one, please, I want you to be attentive. Look up and see the way I'm going to draw it. We have, this is pole, this is F. Now, see the application that I was saying the other time. If you are told that the focal length of a mirror is 10 centimeters, definitely you should know that our C is now going to be 20 centimeters from the what? From the pole. It's going to be 20 centimeters. So it means this one is going to be twice the distance. That if from here to here is 10, from here to here too must be 10. And they now said, okay, now it now means that, you can see, they said we want to take the position number 1. That is beyond C. Definitely our object distance is going to be what? More than 20 centimeters. So let's say it is 25. If it is 25, I'll place it here. Class, see, I'll place it there. Now, after placing it there, see the way I will sketch. What's the first principle? Any ray that is close and parallel to the principal axis, where will it pass? After this, it will pass through principal focus. You have to indicate. That's number 1. Then number 2, any ray that passes through principal focus, where will it be? It will be parallel. Are you there? So, an object is formed where there are 2 intersections of rays. Now you can now see, this is one ray. This one comes this way, and it goes this way. You know I've indicated. Where did they meet? They meet here. So this is where I'm going to have my image. That is where I'm going to have my image. Class, you can, even without looking at something, you can get it. Look at it. Number 1, the characteristic now. Characteristic of the images are what? Formed. 1, it is what? Inverted. That is upside down. Inverted. 2, because it is front in front, it is real. 3, it is between, look at our object. This is our object and this is our image. Where is our object? Beyond C. Now, where is the image produced? In front of C. So, the image is between what? F and C. Are you getting it? The image is what? Is between F and C. You can see. It is upside down. That is inverted. It is real. It is what? Now, the 4th one. It is diminished. Diminished. What do I mean by diminished? It is smaller than the object. That is, the something is smaller than the object. Is that understood? Well, our focal length, what is our focal length? Our focal length is 10 centimeters. Our object, we were told that it is 25 centimeters. That is U. U is the object distance. That is 25 centimeters. Now, if they now ask you, what is the image distance? Of course, your image distance, look at it, your image distance is going to be more than 10. Isn't it? It's going to be more than 10 because it's the front. It can never, our V will be greater than what? It will be greater than 10. But less than what? Less than 20. Am I speaking? It's going to be greater than 10. It will be greater than 10, but less than what? But less than 20. Because less than 20, these are 20. It is not up to 20. Is that not true? So it's going to be less than 20, but it will be greater than 10. And the object is going to be real. It's going to be inverted. It's going to be diminished. Is that understood? The second position is what? Is at C. So, the second position is at C. Well, let us now see. The first diagram, parallel. Where will it pass? It's going to pass through the focus. The next one passes through the focus. Where will it go? You have to indicate. Do you see? If the object, this is how the question could be framed. That is, if the focal length is 10 centimeter and object distance is 20, wow, it means twice the what? The focal length. So, twice the focal length means it is placed at the radius of curvature. And when the object is placed at this, it's going to be formed at the same point. So, characteristic now. What's our characteristic? 1. The image, this is the object, and this is our image. The image is at C. If the object is at C, the image too will be at C. Number 2, it is real. It is real. Number 3, the same size as the object. The same size as the object. And number 4, it is inverted. Inverted. So those are the characteristics. 1, if you are told that the focal length is 10 and the object is placed at 20, I say, twice that, okay, twice. Since it is twice, then it now means the image too will also be at the same point. So if they now say the object, what's our image distance, and they give you 10, you should know that it's wrong. 10 centimeter, you know it's wrong. If they give you V is equal to 15, you know that it is also wrong. If they give you V is equal to 20, automatically it is what? It is correct. Because the image is, the object is at 20, the image too must be what? At 20. Very good. Now, this is our third position, between F and C. Between F and C. Now, remember, when this one was here, the image was, the object was here. Where did we have our image? We have our image here. Now we are having our object here now. We are having our object here. Where are we going to have our image? It's going to be here. Opposite. Object here, image here. Image here, object here. So yeah, let's see. Let's see. This one, any ray close and parallel, it will pass through where? Then any ray that passes here, can you now see? This one is going to be our image. Class, I want you to be very, very careful in this sketch. And if you understand the concept, honestly speaking, you will not have any problem. That is, if you are very, very careful. Now, this one was here. It was here the other time. We have our image here. Now, our object is here. Our image is here. So, we can now say the characteristics now. The characteristic of image formed. One, it is inverted. There is no doubt about that. That is, it is upside down. Two, it is real. Three, it is magnified. Magnified. That is bigger than the object. Magnified. Bigger than the object. And four, behind. Behind what? Behind C. Are you getting now? Behind C. Those are the characteristics of the image formed when the object is placed between F and C. Is that understood? Now, the next one. See, we have dealt with this. We have dealt with this. We have dealt with this. So we are now going to object placed at where? At F. This is our object. It is placed at F. Class, look up. If the object is placed at F, do not forget. If the object is placed at F, we have this. Again. Parallel. Go this way. The other one. Now, class, object is at where? Is at F. Characteristic of image. Of image formed. The image is at infinity. That is, you can never see that image. Is with God. You cannot see it. That is at infinity. That is why they will now say, oh yeah, you say, I cannot see anything. It means the object is standing at where? At the principal focus of that lens or mirror. You cannot see anything. So it means it is at where? At infinity. That is the only characteristic. You cannot say it's real because the rays are not intersecting. They are not crossing. It is when the ray cross, that is when you have the edge. The rays are not crossing. You cannot say it is virtual. You cannot say it is real. You cannot say it's upside down. All you just know that the image is with God. It's at infinity. You cannot see it. Is that understood? The last one. The object is placed at between pole and the principal focus. That is between this. You see. As usual. Let's go. Now, the object is placed between this and this. So we have this parallel. Where will it pass? Focus. Then, the other one, it will pass through C. The moment your ray leaves the surface here, then becomes virtual. Then, they will now intersect. Where they intersect? Behind the pole. So, because the image formed is as a result of intersection of two virtual rays. Then the image too will be what? Virtual. So this one is now represented with broken lines. That is our virtual image. Class, that is the only condition, that is the only situation by which a concave mirror produces an upright image. That is the only condition. That is, if you are told that the focal length is 10, and the object is placed 6. Class, you can see the application. The object is, the focal length is 10. You can see, from here to here is 10. And the object is now placed what? 6 centimeter. So it means less than this. Definitely is going to form what? A virtual image. Is that understood? Now, we have successfully completed the nature of images formed by concave mirror. Now, the convex mirror, irrespective of the distance, irrespective whether it's very close or it's far away, it has only one image formed. That is, the image is always diminished. The image is always what? Is always diminished. One diminished. 2 upright. 3 virtual. Are you getting now? And here we have 4 before C, before F. That is the characteristic. These are the characteristics of the image formed by what? By convex mirror. By convex mirror, irrespective of the distance, whether very close or very far. Now, the moment you are told that it is a convex, you should know that the object, the image will be what? This is the object, and this is the image. The image will be upright. Class, I want to sincerely believe this is clear enough. If you really enjoy the topic, please do subscribe to the channel and like the video. Thank you.